When you've completed this topic, you will be able to recognize the purpose of the digital multimeter, DMM. To identify applications for the DMM, recognize the safety considerations for use of the DMM. The Caterpillar Heavy-Duty Digital Multimeter, or DMM, is a rugged, reliable, and highly accurate tool. With the test leads provided, it can be used to measure voltage, current, and resistance in Caterpillar electrical systems. The multimeter can stand up to the severe conditions found in field service, while providing the accuracy of a laboratory test instrument. Its extra-thick case is made of a durable plastic tough enough to survive a 10-foot drop. Special construction techniques protect the circuits inside the multimeter to minimize the effects of moisture, dirt, grime, and radio interference. Combined with the precision of the circuitry, this means the meter will maintain its accuracy for at least a year after factory calibration. Subsequent field calibration checks and adjustments can be made as required. The DMM is not only precise, it is also very energy efficient. A common 9-volt battery provides up to 2,000 hours of continuous operation. Both the battery and the fuses that protect the meter against excessive current are replaceable in the field. The multimeter provides all the functions needed for both basic electrical and electronic troubleshooting. It can measure voltage, current, and resistance in circuits, as well as individual components. The multimeter has 4 major features. 1. A digital display, used to show measurement readings. 2. A rotary switch, called the function range switch, used to select the mode of operation. 3. 2 test leads. And 4. A row of connectors for the test leads. Another feature of the DMM is its use of triangular warning symbols on the cover. These warning symbols provide important safety reminders about the maximum voltage and current that can be safely measured. Always observe these warnings when using the DMM. These warning symbols also appear in several places in the Caterpillar Special Instruction for the 6V7070 Heavy-Duty Digital Multimeter. Their appearance signals important safety information. Read this information before using the DMM. The digital display is a large liquid crystal display LCD panel that can be read in normal light. The display is of the 3 1/2 digit type. The lower 3 digits can be any number from 0 to 9. While the 4th or highest digit can display only the number 1. The decimal point automatically moves to the correct position in the display according to the range selected. This provides a direct indication of the measurement for each function and range selected. A flashing decimal point indicates the battery should be replaced. An OL overload in the display means that the value measured is higher than the display can indicate. When you see this symbol, try changing to the next highest range setting. These facts apply regardless of the measurement function you select. The rotary switch on the DMM is called the function range switch. To use the DMM, you rotate this switch to select the measurement you want to perform: voltage, current, or resistance. Each of these is divided into ranges for taking measurements at different levels with the greatest possible accuracy. Always select a range larger than the measurement you expect to take. Accurate measurements with the DMM depend on your selecting the correct position on the function range switch. The DMM performs 5 major measurement functions: DC voltage, DCV; AC voltage, ACV; DC amperage, DCA; AC amperage, ACA, resistance, indicated by the Greek letter omega on the switch. The DC volts function has 5 ranges. The 1500 volt range is highest and can measure up to 1500 volts DC. The second highest range, labeled 200 volts, can actually measure up to 199.9 volts. Likewise, the 20 volt range can measure up to 19.99 volts. The 2 volt range can measure up to 1.999 volts. The lowest range is labeled 200M because the highest voltage it can measure is 199.9 millivolts, or thousandths of a volt. You could also think of this as the 0.2 volt range because 200 millivolts are equal to 2/10 of a volt. The AC volts function has 5 ranges. The 1000 volt range is highest and can measure up to 1000 volts AC. The second highest range, labeled 200 volts, can actually measure up to 199.9 volts. Likewise, the 20 volt range can measure up to 19.99 volts. The 2 volt range can measure up to 1.999 volts. The lowest range is labeled 200M. The highest voltage it can measure is 199.9 millivolts, or 199.9 thousandths of a volt. You could also think of this as the 0.2 volt range, because 200 millivolts are equal to 2/10 of a volt. The DC current function has 5 ranges. The range labeled 2 measures up to 1.999 amperes. The second highest range, 200M, measures up to 199.9 milliamperes, thousandths of an ampere, or approximately 2/10 of an ampere. The third switch selection offers one of 2 ranges, depending on the position of the red test lead. With the lead in the A connector, this range measures up to about 19.99 milliamperes. With the lead in the 10A connector, this range measures up to 10 amperes. The fourth range, labeled 2M, measures currents up to 1.999 milliamperes. The lowest range measures currents up to 0.1999 milliamperes, or about 200 millionths of an ampere. Please note that the label for this range includes the micro symbol, which designates millionths. It is read as 200 microamperes. The AC current function has 5 ranges. The range labeled 2 measures up to 1.999 amperes. The second highest range, 200M, measures up to 199.9 milliamperes, thousandths of an ampere, or approximately 2/10 of an ampere. The third switch selection offers one of 2 ranges depending on the position of the red test lead. With the lead in the A connector, this range measures up to about 19.99 milliamperes. With the lead in the 10A connector, this range measures up to 10 amperes. The fourth range, labeled 2M, measures currents up to 1.999 milliamperes. The lowest range measures currents up to 0.1999 milliamperes, or about 200 millionths of an ampere. Please note that the label for this range includes the micro symbol, which designates millionths. It is read as 200 microamperes. The resistance function is divided into 6 ranges. The highest range, labeled 20M, measures resistances up to 19.99 million ohms, or megohms. The M stands for mega, meaning 1 million. The second highest range, 2M, measures up to 1.999 megohms, 1,999,000 ohms. The third range measures up to 199.9 thousand ohms, or kiloohms. Kilo means thousand, and so is labeled 200K. Likewise, the fourth range, labeled 20K, measures up to 19.99 kiloohms, 19,990 ohms. The fifth range, labeled 2K, measures up to 1.999 kiloohms, 1,999 ohms. The lowest range, labeled 200, measures from 0.1 ohm to 199.9 ohms. This will probably be a range you will use frequently. The position to the far right in the resistance sector is not used to measure resistance. It is used to measure the voltage drop across diodes and other semiconductors. The DMM has 4 test lead connectors. The test leads are inserted into these connectors to make the various measurements. The black or negative lead always goes in the common connector, which is labeled COM, and is color-coded black regardless of the measurement function or range. The red or positive lead goes into one of the 3 remaining connectors depending on the measurement. You insert the red test lead in the V-ohm connector for all voltage and resistance measurements. You insert the red test lead in the A connector for AC or DC current measurements up to 2 amperes. You insert the red test lead in the 10A connector for AC or DC current measurements up to 10 amperes. The connector is labeled 10A to distinguish it from the 2 ampere connector. The DMM has 2 test leads, sometimes called test probes. The leads are color-coded. The red lead is the positive lead and is normally placed closest to battery positive. The black lead is the negative lead and is normally placed closest to battery negative. Failure to place the leads in this manner will cause a negative sign to precede the displayed voltage or current reading. When you have completed this segment, you will recognize the battery check and replacement procedures for the DMM. Recognize the fuse inspection and replacement procedures for the DMM. Recognize the probe check procedure for the DMM. A rugged precision instrument, the Caterpillar digital multimeter requires very little maintenance in normal use. It is powered by a single 9-volt battery, 1, and protected by 2 fuses, a 10 ampere fuse, 2, and a 2 ampere fuse, 3, both with a 600 volt rating. Both the battery and the fuses are user replaceable. When the battery is near the end of its useful life, the decimal point in the display will blink while the meter is on to indicate that you should replace the battery. If the display is blank when the multimeter is turned on, chances are that the battery is completely dead. To replace the battery, first turn the meter off and remove the test leads. Then remove the 4 small screws that secure the back of the meter case. Removing the back exposes the meter circuitry and gives access to the battery and the fuses. To get to the battery, you must first remove the fuse for the 10 ampere current range. Then disconnect the battery and replace it with a good battery. You should always remove the battery before you store the multimeter for an extended period of time at temperatures above 120 degrees Fahrenheit, which is approximately 50 degrees centigrade. The multimeter will not measure current greater than the maximum for the range selected. If you try to measure a current greater than the maximum selected, OL will appear in the display to indicate the overload if the current is less than 2 amperes. If the current is greater than 2 amperes for all but the 10A range, or greater than 10 amperes for the 10A range, the fuse for that range will blow to protect the meter. When a fuse blows, the affected current range will no longer operate even though the other DMM functions are working. To check the fuses, first remove the back of the DMM. The large fuse visible upon removing the DMM back is for the 10 ampere circuit. Note, early 6V7070 and all 6V3030 DMMs did not have an internal 10 ampere fuse. Use a fused 10 ampere test lead with any DMM that is not internally fused whenever you use the 10A connector. See your DMM Caterpillar special instruction for the part number of the fused 10 ampere test lead for your DMM. A smaller fuse for the 2 ampere circuit is located underneath the battery. To get to the 2 ampere fuse, you must remove both the 10 ampere fuse and the battery. To remove the 2 ampere fuse, you must hold back the battery isolator and pull on the fuse ribbon. The fuse should pop out. Once the fuses are removed, you can inspect them for any obvious signs of damage, such as a blown element or corrosion. The DMM's resistance ranges are not affected by the fuse blowing, so you can use the DMM itself to check the fuses. On the 200 ohms range, the resistance of either fuse should be no more than that of the test leads, or about 0.1 to 0.2 ohm. A blown fuse will indicate OL. When using the DMM to measure its own fuses, you should temporarily reinstall the back of the DMM to protect its circuit board. When replacing the 2 ampere fuse, remember to wrap the fuse ribbon once around it for easy removal later. Replace fuses only with the special 600 volt rated fuses available from Caterpillar. The part numbers for these fuses are available in the special instruction for the DMM. Do not use automotive fuses. Notice that the DMM has a compartment inside the back cover for a spare 2 ampere fuse. Check this compartment if you do not have a 2 ampere fuse of the correct rating with you. Replacing the fuse that was stored here with a new 2 ampere fuse will ensure that you have a new fuse of the proper type available the next time you need to replace this fuse. When replacing the 10 ampere fuse, only use moderate force to snap the fuse into the fuse clips. The clips are soldered in place and can break or detach under severe stress. After replacing fuses, reinstall the back of the DMM. Tighten all 4 screws snugly and evenly. Avoid over-tightening the screws or damaging the seals under the screw heads. This will ensure a good seal against the outside elements. The DMM and its test lead should be checked periodically for signs of damage. Verify the electrical condition of the test leads by touching their tips together firmly and measuring their resistance. The resistance should be no greater than 0.1 to 0.2 ohm. Higher readings may indicate the leads are not inserted or only partly inserted in the connectors. This also could be an indication that the leads are dirty and making poor contact with each other or with the DMM. Higher readings may also indicate one or both of the leads has a broken conductor. Check to be sure that both leads are clean and firmly inserted in the correct connectors. Wiggling them will sometimes show where a problem is. If necessary, replace the leads. When you've completed this segment, you will Recognize the basic instructions for using the DMM. Recognize the DMM function check. Recognize the relationships between range and function settings on the DMM and the probe sockets. Recognize the relationship between DMM range settings and the circuit under test. Be able to identify the considerations for appropriate functions selection. Be able to interpret readings on display, identify the meaning of the insta-ohms indicator, flashing decimal point, and OL display. Recognize the relationship between the plus and minus symbols in the display and the placement of the positive and negative test probes. Before using the multimeter, it is a good idea to perform a function check to make sure it is in good working order. The function check lets you separately test each of the DC voltage, resistance, and AC voltage functions. To check the DC voltage ranges, insert the test leads into the volt, ohms, and common input jacks. Turn the function range switch to 1500 volts DC and touch the leads firmly together. The display should read 0 volts, plus or minus 1 volt. Check the other DC volts settings by turning the function range switch to each of the remaining DC volts settings while observing the digital display. The display should continue to read 0 volts, plus or minus 1 digit. But the decimal point should move to indicate the correct magnitude. To check the resistance ranges, insert the test leads into the volt, ohms, and common input jacks. Turn the function range switch to the 20 meg-ohm position. With the leads held firmly together, the digital display should read 0.00 or 0.01. With the leads separated, the display should read OL to indicate range overload. Now turn the function range switch to each of the remaining 5 resistance settings, while observing the digital display. With the test lead tips separated, the display should read overload in each position. With the test lead tips in contact, each range should indicate 0 resistance. On the 200 ohm setting, the multimeter may show 1 or 2/10 of an ohm because of test lead resistance. The AC volts function can also be checked by measuring the local line voltage at a convenient AC power outlet. Set the digital multimeter to the 1000 volts AC range. Use caution when inserting the lead tips into the outlet. Keep your fingers behind the guards on the test leads. When working properly, the display will show the line voltage to the nearest volt. Local line voltages vary considerably. If the multimeter performs properly during this checkout procedure, it is fully operational and ready to use. Use these steps on the following screens for making all measurements with the DMM. First, attach the test leads to the DMM. Use the appropriate connectors for the measurement you're making: voltage, current, or resistance. The black lead always goes in the common connector. For all voltage and resistance measurements, the red lead goes in the V-ohm connector. For current measurements, the red lead goes in one of the other 2 connectors. Connector A if the current will not exceed 2 amperes. Connector 10A for currents up to 10 amperes. Do not use the DMM to measure currents greater than 10 amperes. Instead, use the clamp-on ammeter described elsewhere in this course. Select the appropriate DMM function and range setting. The function you select depends on the kind of measurement you're making: voltage, current, resistance. You select these according to the information you need about the circuit and the type of voltage or current present. The AC and DC functions cannot be used interchangeably. For instance, false readings will result if a DC range is used to measure AC voltage or current. The range you select depends on the expected level of the reading. For example, to measure tenths or hundredths of a volt, you would select one of the lower ranges. The higher the expected reading, the higher the range you should select. If you have no idea of the magnitude of a voltage or current to be measured, set the function range switch to the highest range and reduce it until you obtain a satisfactory reading. For the most precise reading, select the lowest range that lets you obtain the reading. For example, while you can use the 1500 volt range to measure a 24 volt battery, the 200 volt range allows you to measure the voltage with greater precision. Turn off the power to the device or circuit being tested, preferably at the battery disconnect switch. You can omit this step only if you're making a DC voltage measurement on the fused or protected portion of a Caterpillar 12 or 24 volt system. The proper way to connect the test leads to the device or circuit depends on the type of measurement you will be making. If you're making a voltage measurement, the test leads must be placed in parallel with the component or circuit being tested. If you're making a current or resistance measurement, the test leads must be placed in series with the component or circuit being tested. If you are making a voltage or current measurement, you must restore power to the circuit in order to obtain the desired reading. If you're making a resistance measurement, power must remain off in order to obtain the desired reading. The meter uses its own power to measure resistance. Other power in the circuit will either cause a false reading or damage the meter. When measuring DC voltage, the readings are in volts for the 1500, 200, 20, and 2 volt ranges. The readings on the 200M range are in millivolts. In the example shown here, the display indicates 1.5 with the selector set to 200M. The reading is therefore 1.5 millivolts or 0.0015 volt. If the display were indicating 1.50 with the function range switch set to 20, the reading would be 1.5 volts. A plus or minus symbol appears in the display to indicate the polarity of the DC voltage being measured in relation to the position of the test leads. A negative reading means that the positive test lead is at a lower potential in the circuit than the negative test lead. Such a reversal should not otherwise affect your reading. When measuring AC voltage, the readings are in volts for the 1000, 200, 20, and 2 volt ranges. The readings on the 200M range are in millivolts. In the example shown here, the display indicates 1.5 with the selector set to 200M. The reading is therefore 1.5 millivolts or 0.0015 volt. If the display were indicating 1.50 with the function range switch set to 20, the reading would be 1.5 volts. Readings on the AC volts ranges are not affected by reversing the positions of the red and black test leads. When measuring DC current, readings are in amperes for the 2 ampere range and in milliamperes for the 200M, 20M, and 2M ranges. Readings on the 200 microsymbol range are in microamperes. When the red test lead is in the 10A connector, the 10A range reads in amperes. In the example shown here, the display indicates 1.500 with the selector set to 2 dCA. The reading is therefore 1.5 amperes. If the display were indicating 1.500 with the function range switch set to 2M, the reading would be 1.5 milliamperes or 0.015 ampere. If it were indicating 1.5 with the selector at 200 microsymbol, the reading would be 1.5 microamperes or 0.000015 ampere. A plus or a minus symbol in the display indicates the polarity of the DC current in relation to the position of the test leads. A negative reading means that the flow of conventional current is into the negative lead of the meter and out of the positive lead. Such a reversal should not otherwise affect your reading. When measuring AC current, the readings are in amperes for the 2 ampere range and in milliamperes for the 200M, 20M, and 2M ranges. The readings of the 200 microsymbol range are in microamperes. When the red test lead is in the 10A connector, the 10A range reads in amperes. In this example, the display indicates 1.500 with the selector set to 2 ACA. The reading is therefore 1.5 amperes. If the display were indicating 1.500 with the function range switch set to 2M, the reading would be 1.5 milliamperes or 0.0015 ampere. If it were indicating 1.5 with the selector at 200 microsymbol, the reading would be 1.5 microamperes or 0.000015 ampere. AC current readings are not affected by reversing the positions of the red and black test leads in the circuit. When measuring resistance, the readings are in ohms for the 200 ohm range, in kiloohms for the 2K, 20K, and 200K ranges, and in megohms for the 2M and 20M ranges. In the example shown here, the display indicates 1.500 with the function range switch set to 2M. The reading is therefore 1.5 megohms. If the display were to indicate 1.50 with the selector set to 20K, the reading would be 1.5 kiloohms. If the display were to show 1.5 with the selector set to 200, the reading would be 1.5 ohms. The ohms symbol, called the insta-ohms indicator, appears in the display whenever the resistance being measured is less than twice the maximum reading for the range selected. This feature helps you to quickly determine continuity in cables and connectors. If you were required to turn off the power before connecting the test leads, turn off the power once again before disconnecting them. The only exception to this is that when you make a resistance measurement, the power is already off. In this practice, you use the DMM to measure voltage, current, and resistance in a sample lighting circuit. For each measurement, you select the correct DMM test lead connector and function range switch position. You also control power to the circuit and determine the placement of the test leads on test points in the circuit. Upon completion of this topic, you will recognize the purpose of the clamp-on ammeter. You will be able to recognize the parts of a clamp-on ammeter. You will recognize the limitations of the digital multimeter amps function. You will recognize the advantage of non-contact measurements. You will recognize applications for the clamp-on ammeter. You will recognize the safety considerations for use of the clamp-on ammeter. The Caterpillar clamp-on ammeter is a portable diagnostic tool you can use to measure current when troubleshooting Caterpillar machines. Unlike the digital multimeter, the clamp-on ammeter can measure the large currents found in heavy-duty electrical systems, like the Caterpillar charging and starting systems, and in some power generation applications. The ammeter lets you measure AC and DC current without making direct contact with the circuit under test. It measures the electromagnetic field surrounding the wire or conductor. This non-contact inductive measurement works on the principles of electromagnetism. The clamp-on ammeter has a handle, 1, and a lever, 2. When squeezed together, they open the spring-loaded jaws, 3, that allow you to fit the ammeter around a conductor. The opening in which you position the conductor or wire is the aperture, 4. The core closure area, 5, is the place where the top and bottom jaw touch. When the jaws close, the elements in the core closure make contact, completing the coil circuit around the aperture. This is why the core closure area must be tightly closed and free of any foreign material when making measurements. The ammeter also has a trigger switch, 1, to turn the meter off and on. You can lock the trigger in the on or off position by sliding the trigger slide lock, 2, back toward the trigger switch. You don't have to lock the ammeter in the on position to take a reading. The digital display continues to display a reading for 5 seconds after you release the trigger. This can be especially helpful when making a measurement in hard-to-reach places where the display may not be visible. The digital display, 1, is located on the top of the ammeter. An arrow will appear at the top of the digital display when the ammeter's batteries need to be replaced. The clamp-on ammeter requires 4 AA-sized batteries. To replace them, you remove the screw, 2, on the back of the handle. Also on the back of the ammeter are 2 output jacks, 3. These jacks allow you to use the clamp-on ammeter with the digital multimeter, as described in the Caterpillar special instruction for the clamp-on ammeter. Just below the digital display is the DC Zero Adjust dial, 1. Use this dial to set the digital display to 0 before taking DC readings. Above the digital display is the AC-DC mode switch, 2. Moving this switch allows either AC or DC current to be measured. A current flow indicator arrow, 3, appears on the ammeter above the AC-DC mode switch. The clamp-on ammeter can measure current from 1 to 1200 amperes, an advantage over the multimeter, which only reads up to 10 amperes. A second advantage of the clamp-on ammeter is that you can take a measurement inductively. This means the clamp-on ammeter reads the current without breaking the circuit or disturbing the insulation on conductors. This makes the ammeter ideal for measuring the output current of batteries and alternators. Key advantages of an ammeter are that it measures 1 to 1200 amperes by itself, measures 0.1 to 1 ampere when used with a DMM, measures current inductively, so you don't have to break the circuit. Key limitations of DMM: cannot measure current greater than 10 amperes, must break the circuit to measure the current. This symbol appears in the instructions for the ammeter. It indicates important safety information. Read this information before using the clamp-on ammeter. For further details, see the Caterpillar special instruction for the 8T900 AC-DC clamp-on ammeter. When you have completed this segment, you will recognize the battery check and replacement procedure for the clamp-on ammeter. There are 2 things generally required for routine maintenance of the clamp-on ammeter. Keep the jaws clean. Replace the batteries as required. The jaws of the ammeter must close completely to obtain an accurate reading. Therefore, it is important to keep the jaws of the ammeter free of any dirt and debris that might keep them apart. Use a clean, soft cloth or cotton swabs and alcohol as required to keep the jaws of the ammeter clean. The ammeter is powered by 4 AA size 1.5 volt batteries. You can use either alkaline or mercury batteries, but do not combine alkaline and mercury batteries in the ammeter. You will get approximately 30 hours of use from 4 alkaline batteries and approximately 60 hours of use from 4 mercury batteries. Always remove the batteries before storing the ammeter for an extended period of time at temperatures above 120 degrees Fahrenheit, which is approximately 50 degrees centigrade. When it is time to replace the battery, an arrow appears at the top of the digital display. Your ammeter may not give accurate readings if this arrow is showing in the display. When you see the low battery indicator arrow, change the batteries. The ammeter's battery replacement procedure has 6 steps. Step 1. Loosen and remove the battery access screw in the end of the ammeter handle. Step 2. Remove the end cap and slide the battery holder out of the handle. Support the battery holder to prevent unnecessary stress on the flexible leads. Step 3. Snap the 4 old batteries out of the holder. Step 4. Snap the 4 new batteries into place in the holder. Be careful to match the positive and negative ends of the battery with the plus and minus symbols on the holder. Step 5. Slide the battery holder back into the handle, being careful not to pinch the wires, and tighten the access screw. Step 6. Pull the ammeter power trigger. Digits should show on the digital display. Whenever the low battery indicator appears on the clamp-on ammeter's digital display, follow these 6 steps to replace the batteries. 1. Remove battery access screw. 2. Slide battery holder out of handle. 3. Snap old batteries out of holder. 4. Snap new batteries into holder. 5. Replace the battery holder and tighten screw. 6. Pull power trigger and check digital display. When you have completed this segment, you will recognize the basic instructions for using the clamp-on ammeter. Recognize the clamp-on ammeter function check and adjustment, including the significance of the battery check arrow. Recognize the considerations for appropriate mode selection, AC or DC. Recognize the procedures for installing the clamp-on ammeter, selecting the appropriate test point for measuring current, and interpret readings on the clamp-on ammeter display. The 8T900 clamp-on ammeter is an invaluable tool for diagnosing problems in Caterpillar equipment, especially if you're troubleshooting heavy-duty electrical systems. This topic demonstrates the 6 basic steps to using the ammeter effectively. First, select a point along the conductor to measure. This point should be away from other conductors or metal objects, as the magnetic fields of these other conductors can affect the reading. This is especially true for components such as the alternator and the starter, which have magnetic coils inside. Second, place the AC-DC mode switch in the correct position to measure the type of power in the circuit. In this case, the correct mode is DC, because we're measuring the output from the battery. Third, turn on the clamp-on ammeter by pressing and holding the power trigger switch, or locking it in the on position. Allow the ammeter to warm up for 60 seconds in the on position. Then, check the digital display to see whether the low battery indicator is showing. If the low battery indicator is showing, release the slide lock to turn off the ammeter and replace the batteries. Fourth, zero the ammeter to compensate for stray magnetic fields. To do this, hold the closed jaws of the ammeter 2 to 4 inches from and at a right angle to the conductor, whose current is to be measured. Then rotate the DC zero adjust control dial until the digital display reads 0. An inability to zero the ammeter can be caused by magnetization of the ammeter core. When this occurs, demagnetize the core by turning the meter off and on several times. Fifth, place the ammeter around the conductor. Open the jaws of the ammeter by squeezing the jaw lever and position the aperture around the conductor. Then gently release the jaw lever, making sure the conductor is in the center of the core aperture and the jaws close completely. Do not let the jaws snap shut, as this can cause the ammeter to lose its zero adjustment or damage sensitive electronic sensors inside the ammeter.
Sixth, observe the reading in the digital display. Remember that the display reads directly in amperes. Be sure to hold the ammeter so that the conductor is in the center of the aperture. A minus sign in front of the reading means that current is flowing in the direction opposite the arrow on top of the ammeter case. If there is no minus sign, the current is flowing in the same direction as the arrow on the case.
By following these 6 basic steps whenever you use the 8T900 clamp-on ammeter, you will obtain accurate measurements and minimize the possibility of damage to the ammeter. Perform the ammeter zero adjustment before taking any DC current measurements. While performing the adjustment, hold the jaws of the ammeter 2 to 4 inches, 50 to 100 millimeters, from the place you have selected to take the reading. By zeroing the ammeter near the place you are going to measure, the effect of stray magnetic fields and the Earth's own magnetic field will not affect the reading. The zero adjuster has no effect on any AC readings you take with the ammeter. The core of the ammeter can be magnetized by surges of DC current, making it impossible to zero the meter. When this occurs, 1. Demagnetize the core by turning the meter off and on several times. 2. Attempt the DC zero adjustment again. If the meter will zero, it is ready to use. If the meter will not zero, it must be calibrated before use. See the special instructions for the ammeter. The maximum wire size you should measure using the clamp-on ammeter is 0.75 inches, or 19 millimeters. Do not attempt to measure wires larger than this with the ammeter. The thickness of the wire will not allow the ammeter jaws to close properly and will result in faulty readings. In some cases, it may not be possible to position the ammeter to match the current flow. When this happens, you will see a minus sign in front of the reading. This indicates that current is flowing in the opposite direction from the arrow on top of the ammeter. The minus sign does not change the value of your reading in any way. In this practice, you use the clamp-on ammeter to measure current in a sample DC circuit. You select the appropriate test point for the ammeter as well as the correct mode of operation. You will follow the 6 basic steps for using the ammeter to make 2 different measurements.